4. So question 4 is still looking at networks, but specifically looking at really how the internet works. And question 4 is a 5-mark question, so quite a few marks available just for one question in this exam. And this is a paper that definitely looking as a whole class, there was marks dropped. So if that was you, you may really need to try and focus on developing your understanding here, and there's work to be done here by all of us to help with this topic. So the IP address 192.149.119.226 is linked to the website with the URL of https www.ocr.org.uk. Okay, now hopefully that doesn't sound like new information to you in terms of understanding what an IP address is. It's a group of numbers, and that group of numbers represents a website or a URL. Okay, URL stands for Uniform Resource Locator, and it's the whole website. Okay, so it includes the protocol, the HTTPS, the www, the .org, and the .uk as well. Now, the domain name is more things like ocr.org, for example, would be the domain name. So the URL is the whole address, including everything. So when HTTPS www.ocr.org.uk is entered into a browser, so a browser would be Google Chrome or Web Internet Explorer, something like that. Okay, the website homepage is loaded. So you are just describing the relationship between the website URL, the IP address, and the web server. So really, how does that process happen? And I've actually got 2 images here I'm going to talk through before I answer this question. This first image is off the BBC Bitesize website, and it's quite a nice sort of flow chart, as it were, just through the key tasks of that process. So a user enters www.bbc.co.uk. bbc.co.uk is sent to a name server's IP address as a DNS query. Now, that's quite complex. In our computing lessons, what I've said is the URL will go to something called the domain name server, or the DNS, which is exactly what this is here. But they've used slightly different terminology in terms of the name server and the DNS query, but it's the same thing. The DNS returns, what the DNS does, it's like the post office, it returns the IP address matching it with the URL. Okay, it returns it back to the web server. The web server, so the user, then knows where to go to find it. So it would go to the web server. So here it says here, server at the IP address returns file or data, and all of a sudden that is loaded. So that's one image there I thought was quite nice. The below image is another one I think is also really nice. This is very similar steps, but it's just a different way of illustrating it. So the client computer is here, and you can see the web browser. They've got the Firefox, Google Chrome, the Safari, the Opera web browsers there. So what's happened here, it's saying to the domain name server, what is the IP address of 101computing.net? So that's the domain they've typed in there, or the URL. It's gone to the DNS. The DNS has located the IP address, returned it to the web browser. Number 3, the web browser has sent that IP address to the web server. The web server has then returned it. Okay. So we can see this process sort of, it goes to the DNS, back to the computer, then to the web server, and then back to the computer. So both images here illustrate this process. So it's probably worth revising these images and going over them if you dropped marks. I'm going to delete them now, and I'm going to type in an answer that we would have liked to have seen in the exam. So the first thing I'm going to say is the URL is typed into the web browser. Okay. The web browser sends the URL to the domain name server or domain name system. Okay. Now, the question doesn't ask you why we use URLs. I think some of you may have said, we remember URLs, we use URLs because they're easier than IP addresses to remember. And that's correct, well, it's true, but it's not what the question is asking you. The question isn't asking you to identify why we use domain names. Okay, the question is asking you to explain the process. So the web browser sends the URL to the domain name server. DNS matches the URL with an IP address. And I'm going to put in here as well, because you could have said, if the DNS cannot find the IP, it will look in another DNS or return an error. The DNS sends the IP back to the web server, web browser. Then the browser sends the request to the relevant web server. The web server processes the request and returns the web page. So I've bullet pointed the images I've just seen. I definitely would be pausing this video, maybe writing this list out a couple of times, to really try and understand it, and maybe reading these texts alongside those images may be useful. But this process here really represents how web page is loaded. So I hope that makes sense. Let's move on to the next question then. Computers access the internet using the TCP/IP model. The TCP/IP model uses layers, including the application layer and transport layer. Now, we don't need to remember the names of the layers. I hope I've made that clear in lessons. You will not get asked a question regarding the names of the layers. It just won't happen. It's not in the specification. But what you do need to know is why we use layers. And this question is a very typical type of question you may see. Now, the TCP/IP, the Transmission Control Protocol, Internet Protocol model, uses 4 layers. And we just need to know why they use them, as I've already mentioned. So, the main reason we use a layer is that they can be worked on or developed without really affecting the other layers. So, a layer can be developed, or changed without affecting the performance of other layers. Each layer has its own purpose. Now, the whole idea of communicating over a network is incredibly complex. This could be a huge list of different things that happen during that whole process of communicating via TCP/IP. So if you use layers, you can say each layer has its own purpose, which just makes it easier to manage. It keeps it self-contained. So each layer has its own purpose, which keeps tasks self-contained. That's plenty for 2 marks there. It's probably more than enough. Each layer can be programmed independently of the other layers. Each layer is easier to manage. So there we have it. We've got more than 2 marks available there. I hope I've made it clear exactly what you need to know regarding layers. I don't have a quick guide to learning the names of protocols. I really don't. I think there's different ways you can memorize them. It's something we need to work on maybe as a class. I think there's a real split between the class of who got all of these and who just got none of them. So there's a number of protocols we need to know. TCP/IP is an example of a protocol. We need to know a number of others. And there's 3 regarding emails. There's ones regarding downloading of web pages or transferring of files. Really, it's just worth remembering them. We have covered these again, but definitely revisit them. So 4 marks available here. Sending an email from one mail server to another. So if I'm sending an email to one mail server here, so I'm emailing someone, my computer will use a protocol to send that email to that mail server, and that's known as. So I'm going to type out the full word, not just the initialization for you. So it's Simple Mail Transfer Protocol, SMTP for short. Transmitting a file from a client to a server. So this is going to be File Transfer Protocol, FTP for short. Visiting a website using a web browser. So That would be, I think this was probably the one most people got correct. Now I'm going to type the whole thing out. Hypertext transfer protocol. And I'm going to put the secure on. You could have just had HTTPS there. Downloading an email to your computer. Now there are two different types here. You could have had the post. Take red font. You could have had the post office. Or you could have had the instant message access protocol. Either one of those would have been absolutely fine. So that was either POP, or the IMAP. Okay, so that's question 4 done now. Please look back at that. I really encourage all of you to focus a lot on question 4A because it was a lengthy question to study.